Hi everyone, thanks for joining today. I'm Ellie from the PTI and I'm pleased to welcome you to today's online course, which is an Enrich session on place value and rounding. If you're not familiar with the PTI, we're a charity supporting teachers to develop their specialist subject knowledge by providing a wide range of CPD run by subject experts and course leaders. Here are some aims for today. So to reflect on how to teach maths in an engaging, connected and enriching way, and to explore how tasks from the Enrich secondary curriculum mapping document can be used to develop students' reasoning and problem-solving skills while offering opportunities to build fluency through purposeful practice. Now I'm pleased to pass on to Alison and Charlie, who will be leading today's session. So thank you very much, Alison and Charlie, and I hope you all enjoy today's course.
Thank you so much, Ellie. Hello, everybody. Really good to see people joining. A little bit of an introduction, first of all. So one or two familiar names, but if you don't know me, I'm Alison Kiddle. Until a couple of years ago, I worked at Enrich with Charlie, who's going to introduce himself in a minute. I'm now freelance, but still work with Charlie whenever I get the opportunity. So it's an absolute delight to be here today talking about Enrich. Charlie, do you want to say hello?
I'll say hello, and it's a pleasure to be working with you again, Alison.
Super. So I'm going to start then by sharing my screen, because everything that we have a look at on Enrich today, I'm going to be showing people how to navigate it. And I'm also going to be putting links in the chat. So if you want to follow any of these links and have a look at them, then you can do. We're also going to be sending all the links out afterwards, so don't worry if your browser only lets you look at one thing at a time and navigating away from the Zoom call isn't possible, because we are going to be screen sharing, so we're going to be showing you everything and you'll have the links afterwards. But the first thing that we're going to look at then today, we're talking about place value. So we're going to do a task to get everybody's brains warmed up a bit. We're going to do dicey operations. So if you haven't already got a pen and paper next to you, you need to very quickly grab one. And then Charlie, do you want to tell us what we're going to be doing?
So game one, which is the one that...
Let me just make this a little bit bigger. Is that better?
It is.
Super.
So Alison is going to simulate throwing a dice, and every time she does, she'll tell us, or she'll show us what the score on her dice is, and we're going to have to decide where to place that number. So in the units column, in the tens column, or in the hundreds column of the top, middle, or bottom 3-digit number. After she's done that 9 times, we'll have 3 3-digit numbers, which we'll add. And the challenge that we're being set, because I'm going to have a go at this at the same time, is to get as close to 1,000 as we can.
Okay, so now I haven't actually got any dice with me because I'm not at home at the moment. I'm on my travels, and so I thought I wasn't going to be able to roll the dice, but then I remembered that Enrich very helpfully has an online set of dice. So I'm just going to show people how to navigate to that, because it's very useful to have. Let me just get rid of that. So yes, from the Enrich homepage, if I go to the secondary teachers homepage, which is the big green button on the right, and then scroll down in this left-hand box, there is interactive and printable resources. I'm going to go to the interactive resources, and then at the top of the page, one of the general interactives is the Dyson spinners. So if I click on that, it will give me dice or spinners to throw. And now it's brought up the one with the numbers on, and I don't like the one with the numbers on, but I know if I go to this purple cog in the corner, I can have dots instead of numbers. Would you like me to do a 1 to 6 dice or 0 to 9 for this, Charlie?
1 to 6, please.
1 to 6. Okay, so if I click on current window, it will reload, and now I've got dots instead of what do you call it? Now, did you want to show us what you're doing under the visualizer, Charlie, or do you just want me to keep track of what numbers we've had so far on here? I don't mind.
No. I think we'll all work independently, so I'm
Okay.
happy not to show.
Okay, so I will be the scorekeeper and keep track of what numbers we've had so far in case somebody misses one then. So let's start with that 6.
Do you want to zoom out a little bit so that
Okay.
we can see the whole of that interactivity?
Yeah.
We can't see the bottom. There we are.
Is that better?
Much better, thank you.
Okay, right. Okay, so has everybody got their grids drawn 3 by 3, ready to start putting the numbers on? Remember that you're trying to get the closest to 1,000. So your first number is going to be the 6 that it auto-generated when it came up. So in one of those cells, you're going to need to write a 6. And I'm just going to keep track here that we've had a 6. Okay, I'm going to assume everyone's ready for their second number. And it's a 4. So far, we have had a 6 and a 4.
We're expecting everyone to just make a decision.
Quick decision, yeah. I don't want to give people too much thinking time. Another 4 then. So put your next 4 in. And 2 is next. So decide where you want to put your 2. And a 5. So you should have more than half your grid filled in now. And a 1. And a 2. And another 2. And there will be some people here who feel that they've made bad decisions because now they've only got one spot left to fill and they're going to have to fill it with a 4. Okay, so you should now have all of those cells filled up and you can add together your 3 3-digit numbers. So I'm just going to give everyone about 30 seconds to do that adding up. And then once you've got a total, pop it in the chat and we'll see who got closest to 1,000. So I hope you're doing your adding up as well, Charlie. Oh, we've got a 903 from Anna. Fatma's got 1,398. Charlie, I don't believe you got 993. 1,020 for Theo.
I've played this game before.
Oh, I suppose you have. Yeah, we've got some in the 1,100s, some in the 1,200s. Oh, 905. Yeah, okay. So that's 95 away. Oh, Will got 993 as well. I wonder if you did it the same way as Charlie did, Will. We might get Will to explain what his 3 numbers were. Did anyone get closer than Will and Charlie? I think most people have posted their answers now. Will, would you like to put in the chat what the 3 numbers were that you, the 3 3-digit numbers were that you ended up with? And at the same time, Charlie, I'd like you to tell me the story of how you filled your grid in. So where did you put the 6?
Okay, so the numbers you've got on your screen in handwritten, Alison, are the order in which they appeared.
That is the order in which they came out, yes.
So I decided to put the first 6 in the hundreds column.
Okay.
Because I wanted to give myself as much time as possible to fill the other 2 numbers, hopefully with suitably low numbers.
Okay.
And because there was a chance I was going to go over 1,000, the 4 and the 4 and the 5 all went into the units column rather than the tens column.
So did you do 4 and 4 as your next 2 moves then?
Yes, and the 2 went into the hundreds column.
Okay, and then the 5 went in your last unit space.
Yes, So
Okay.
I had 800 and a little bit, and I was hoping for either a 1 or a 2. And luckily the 1 turned up. So I had 900. And then I was hoping the 3 next numbers would add up to, well, ideally 9. They added up to 8. So 2, 2, and 4 went in the middle.
So you had 624, 224, and 145. So that's very similar with what Will ended up with that he's put in the chat for us, which was 244, 624, and 125. So this would be a nice opportunity in the classroom to talk about why Will's total and Charlie's total ended up being the same, even though they used slightly different numbers to get it. And that's getting us into this topic that we're talking about of place value, because it sort of doesn't matter how you commute these numbers within the hundreds, tens, and units column, because you're gonna, when you add them up, it doesn't matter, is what I'm trying to say. Good. So yes, and then you added them up and you got 993, is that right?
Yes, and we called this a game because if 2 people were playing this, or 2 pairs were playing against each other, then you could have a scoring system. Will and I were 7 away from our target, so we would be penalized 7 points, but other people were further away, they would be penalized accordingly. And perhaps after several rounds, if you've been penalized a total of, I don't know, 500 or 1,000 points, then you're the loser. Or you look at the, yes, something like that, rather than just, 1 point for winning and nothing for losing.
So I know there's something that you rather like to do at the end of the game. I'm not sure it's going to work for this, because I don't think we could have done very much better. But
couldn't we? I think we can improve on 993, Alison.
Can we improve on 993?
Shall we accept that challenge to everybody? I think we can, very slightly.
We're not going to be able to do much better.
No. But I think we can end up just 2 away from 1,000. Can't we?
I don't know. You're better at this than I am. Lots of people in the chat think we can.
Yes, I can get 1,002.
Okay.
Oh yeah, and other people have. Yeah, so we can get 2 away. Yeah, Anya has done exactly what I did. If you look at the last.
Oh, right, yeah.
Swap the 5 and the 4.
Okay, and that's then going to, because I've moved a 5 from the, yeah, that's going to go up by 1, and
you're
that's
going to go up by
down.
10.
Yes, up by 10, and then
down by
1.
1. So in total, you're going to go up by 9.
Yeah. So that's a nice thing to do at the end of the game, to say, are there any pairs that I can swap, and how is that going to affect the total?
I mentioned that if we were playing this as a game in a classroom, getting students to work in pairs is quite good, because then they've got to think strategically. They've got to think about which cells to fill in, or which columns to go filling in first. And having a partner means you've got to negotiate and justify, argue, convince each other. So it's quite good in that respect.
Yeah, and you've got the element of chance in there because you've got the dice, so you don't know what the numbers are going to be until you've rolled them all. But then at the end, you can do this process of, could I have done better if I use the numbers in a different order, if I swap them around. So this idea of I have funny feelings about games, Charlie, because I always lose them. So I'm always looking for ways to turn a game into something that's more collaborative, and that we're trying to do the best that we can with the numbers we've got, rather than trying to beat the other person.
But one issue that does crop up, it seems to me, is that you don't want the last empty cell to be in the hundreds column, because you may be hoping for a 3 or a 4, and if you get a 1 or a 6, you're going to be a few hundred out. Or you may be hoping for a 1 and a 2, or 1 or a 2 and end up with a 5 or a 6.
Yeah.
And so there's something to, that you can have a discussion about significant figures. And the hundreds column, the digits in the hundreds column are going to be your most significant figures. And one of the reasons why I put the 6 in the hundreds, I was a bit tentative about it, but it's such a large number. But because it's so significant, I want to fill my hundreds column as quickly as possible while I've got as much choice as possible. And I was lucky, but the last thing you want to do is leave a cell in the hundreds column empty right at the end,
because there's so much variability in what you could end up being 500 out if you've made bad decisions, whereas if it's going in the units column, it's only going to make a difference of 5 to your answer.
Yes,
at most.
and that's the kind of strategic thinking discussion that would be good for students to have.
Yeah, and I think if they've played this game maybe half a dozen times, and then bringing the class together to have those strategic discussions, then giving them an opportunity to go back and play it again a couple more times, to put into practice strategies that they've shared, but also strategies that they've heard from other people. And of course, all the time that this is going on, they're practicing thinking about hundreds, tens and units. They're practicing thinking about their column addition to work it out. And they're starting to think about significant figures. So yeah, that's probably why we picked this as an activity to share, isn't it? Because it's got quite a lot going on in it.
But like you say, the business about being competitive sometimes spoils the quality of some of the interactions in the classroom. I quite like the idea of rolling the dice 9 times, writing the digits on the board, and just set the students a challenge. What's the best we can do here? Can we get to 1,000? If not, can we justify, what's the highest we can get? How can we be sure that it's the highest? I think the useful conversations to be had just on that basis.
And I think it's nice to have both, isn't it? So that those who are motivated by that element of competition get that thrill to get them going, but those who are put off by it have a way that they can access the task as well that doesn't put so much pressure on. I think what we're going to do now then is I'm going to hand over to you, Charlie, so that you can share what's going on under your visualizer, and you're going to introduce me to a problem that I don't really know. So given that I couldn't work out the answers for dicey operations, then it'll be interesting to see whether I can work out the answers for a problem that I've never seen before. So would you like to introduce us to Less is More?
Can you see?
I can see a blank piece of paper.
Okay, so on the website, Less is More looks a little bit like this. We're going to show you the problem on the website later on.
Yeah, and I've just put a link in the chat for anyone who wants to cheat and look at it straight away.
And we could play this as a game, just like Alison did a minute ago. And we could throw dice 8 times and ask students to place the 8 digits as they go along, and they need this 2-digit number to end up being less than that 2-digit number, and on the second row they need this 2-digit number to be less than that 2-digit number. And so we could, just like Alison did with dicey operations, we could decide where to put the numbers as we go along. And so let's imagine, we're not going to, it takes too much time. So let's imagine that we've got the numbers 1 to 8. And so one possibility would be to say, okay, well, I could put, say, the 4 and the 1 here, and I know that that's less than 68. And I know that, say, 23 is less than 57 or 75 either. And so that statement on the top row is correct. And this statement on the second row is correct. That number is less than that. That number is less than that.
So I'm noticing again, Charlie, that if I was filling these in as I was going along with the dice, I could have left my one of my digits until the end, one of my tens digits, and then have to put a number in that breaks the inequality. So if that 2 had been the last number to come up, but instead of getting a 2, it had been, say, a 9, and I'd got 93 is less than 57, I'd have a problem because that wouldn't have been mathematically correct.
Absolutely. Okay, now, the way that we score this game is that if you've got the 2 sentences, the 2 statements correct, your score is the sum of these 2 numbers. So in this case, I would have scored 64 points. Now, the tension in this game is you want the numbers on the left to be smaller than the numbers on the right, but you want the numbers on the left to be as big as possible, because that's going to determine your score. Okay? And if only one line had been correct, so for example, if indeed I had a 93 here, then obviously that second line would be wrong.
So it scores nothing?
Would have been 41.
Okay.
Would have been, so I only get the score of the line that is correct. If both are correct, I add them together.
And if neither are correct, I score 0?
Absolutely.
Okay.
Okay, so in this case, I would have scored 64. I could have done a lot better. So my challenge to everybody, including Alison, is can you do better? How could you do better than 64?
Okay, so I think I'm going to give everybody else a little bit of thinking time to make up for the fact that I don't have any good ideas just yet. I'm going to do a little bit of doodling. I've got pen and paper in front of me here. So I've got a 2-digit number is less than a 2-digit number, and a 2-digit number is less than a 2-digit number. And I need to use the digits 1, 2, 3, 4, 5, 6, 7, and 8. And I want the numbers on the left-hand side to be as big as possible, but still less than the numbers on the right-hand side. Okay, well, this session is all about place value. So I'm guessing that place value is going to have something to do with my strategy. And I know that when we did dicey operations just now, we worked from the most significant digit to the least significant digit when we were deciding what to place where, because we had more degrees of freedom. If like you get wiggle room from the units, but the tens is so I can't put an 8 in the tens column on the left hand side because I wouldn't be able to make anything bigger than 80 on the right hand side. But I could put a 7 in the top left, and then an 8 in the third box along yes, that one, because 70 something is definitely less than 80 something.
But it's also a way of getting a very high score because you've got, you know, when I've got
a number in the 70s, yeah, which is, you know, even if I mess up the second inequality, I've still scored more than you because you got 64 before. And I've definitely got a score of 70 something. Okay, I think I want to do the same then with the 6 and the 5. And so put 60 something on the right hand side and 50 something on the left hand side. And okay, so the inequalities definitely have to be true now. And so it kind of doesn't matter where I put the other 4 numbers, because it's not going to make either the inequalities false. So I should just put the biggest ones on the left and the smallest ones on the right. So I'll put the 4 and the 3 on the left hand side and the 2 and the 1 on the right hand side.
And of course, it doesn't make any difference whether you put the 4 at the top and the 3 at the bottom, or the other way around.
No, it's just like when you and Will had the numbers in a different order, and you still got the same in Dicey.
And again, what's significant is what's in the tens column. And like you said, once you decided on that, the rest was immaterial. And your score, because both lines are correct, your score here is 127.
Which is nice because it's 1 less than a multiple of 2.
So that is indeed correct and nicely explained. And it seems to me that offering this challenge to students before they play the game is quite nice, because it forces them to think about the significant figures and what kind of score might be possible. Of course, there's an element of chance when you're throwing a dice, but it's nice to be able to come up with a convincing argument that you've got the largest possible total. Now,
yeah, and I'm imagining that after setting this challenge, you could either have students in small groups explaining to one another how they can be sure that they've got the maximum, or if you'd been circulating the classroom while they were working and you heard someone had a particularly good explanation, you could invite that student to come out and draw on the board and explain their thinking. So it's quite nice for getting a little bit of proof and reasoning into Key Stage 3 classrooms.
Sorry. Okay, so some of you may have known this problem because it's been on the site for a while, the one that we've just done. So we've now created a new problem, and instead of calling it less is more part 2, we've called it more less is more. And this is what the first part looks like. So again, 8 cells, and you can play this as a game with dice, but I think it's quite nice to be thinking about what happens if you imagine rolling a dice and getting all the numbers from 1 to 8. So I'm not going to go run through, but you can see what's happening. You're going to have a 2-digit number added to a 2-digit number, and you need this to be smaller than the sum on the right. And just like before, the tension is you want the sum on the left to be smaller than the sum on the right, but your score is going to be the result of the sum on the left. So yes, you want this to be smaller than that, but you want this to be as big as possible. So we'd like to give you some time to decide on where to put the numbers 1 to 8. This time, Alison's not going to talk you through her reasoning, but we're hoping that you'll use similar reasoning to the one that Alison used for the previous problem. What we'd really like you to do in the chat is write down the number of points you think you could score. So don't tell us how you did it. Just like at the first activity that we did, we wrote the totals and see if anybody can get to the maximum possible. Of course, I'm not going to tell you what the maximum possible is. So don't give away how you're constructing your addition, how you are sharing out the digits, but see what the maximum total is that you can get.
So a couple of people have dropped their answers in the chat, and I think I can get the same answer that they did. But as we've already established, I'm not very good at adding up, so I could be wrong. Do we want to give Andrew or Laura an opportunity to explain some of their thinking for this?
Okay, and in particular, you and I, Alison, have been emphasizing sort of the order in which we fill cells, or which numbers we choose to place initially. And this leads to a discussion about which are the more significant figures. So, Andrew.
So Andrew or Laura, you can type in the chat if you want, but you're also very welcome to unmute yourself and talk to us if you're happy to do that. That might be a little bit easier, but you've both put an answer of 134. It would be interesting if you can explain the reasoning that you used to get there.
Just to answer Anya's question about can you get a maximum of 161, very quickly, the answer is no to that.
Okay, Andrew, go for it.
So I looked at numbers, started with the tens again, and I spotted 8 had 5, 13, 6 and 7, 13. So I paired the 6 and the 7 together on one side and the 8 and the 5 together on the other.
Can I check, Andrew, does it matter which side I put the 8 and the 5 and which side I put the 6 and the 7?
No.
Okay, so I could put the 8 here and the 5 here, the 6 here and the 7 there. So you've used the largest 4. And so far, I will guarantee myself to have 130 on the left, and I've got 130 on the right.
Yeah. So the next thing I spotted, 4 and 1 and 2 and 3 make the same. So we can't have it be the same because it's got to be strictly less than. So I had to pair up the 3 with the 1 and the 4 with the 2. The 4 and the 2 had to go on the greater than side, and the 3 and the 1 had to go on the less than side.
Okay, so 1, 2, 3, 4 add up to 10. If I have them adding up to 5 each, then I would have 135 equals 135. So instead, you've got one side adding up to 6, which is the 4 and the 2, and the other side adding up to 4, which is the 3 and the 1. And you get 134 there, and you get 136 there. And if that had been a less than or equal sign, you could have got 135 on both.
Yeah.
Very nice. Thank you very much indeed, Andrew. That was a lovely explanation.
Yes, indeed. So the idea, I think if I was using this in the classroom, I'd want the students to have a go at this challenge before setting them off on the game, where they've been able to explain and consider the options and justify their answers, and get quite good at appreciating the significance of the units in the tens, columns, and so on. And then after this, playing the game like we were suggesting earlier with the dice. Now, I said that this problem is called more less is more, and there isn't just one more less is more. Here's the next challenge. Now, so the other one was, I think, called plus plus on the site. Now this is take take. So again, 8 cells. I'm going to give you 8 digits, and I want the result of this subtraction to be less than the result of that subtraction, but the score is going to be the result of the subtraction on the left. So again, you want this to be smaller than that, but you want this to be as big as possible. So again, we'll give you a few minutes, and just like before, can you put in the chat what you think the highest possible score is?
In fact, no, don't put what you think the highest possible score is, because I'm feeling uncomfortable now. I've been doing a lot of work lately on maths anxiety, and I don't immediately know how to solve this. And so what I'm thinking is a strategy that I use when I'm feeling anxious is I just want to find a solution. I want to put 4 numbers on the left and 4 numbers on the right so that the inequality is true and so that I get a score. And then once I've got a score, I'm going to see if I can improve on it. So if you want to put something in the chat that is a possible solution, and then we'll see what the highest possible score is that anybody suggests, and then nobody needs to be feel bad if they don't get the maximum thing first time, which is good because I still don't know what the answer is, even though I just talked for 30 seconds to try and give myself some thinking time. So let's have some quiet thinking, shall we?
Okay.
Well, I've got an answer. I don't know if it's correct. I mean, I know that the inequality is satisfied. I don't know if I suspect it's the best you can do because reasons. Of course, it is possible that if I actually do the arithmetic, it turns out wrong, because I was trying to use the clever strategy before that Andrew used when he was explaining to us, where he was pairing digits off to use together. I think it works.
Have you got more than a score of 50, Alison?
I've got a score of more than 50, yes. Ah, that's a very interesting strategy, Anya. So yes, if I want the left to be less than the right, but I want the left to be as high as possible, then getting the subtraction on the left to be close to the subtraction on the right is going to help me with that maximization, isn't it? Because it feels as if I would have wasted digits otherwise, if they're not close together.
Though I imagine, if we think about the previous problem, Alison, where we put some large numbers, when we're adding, we put some large numbers in the tens column. You could put small numbers in the tens column and the large numbers on the right and on the units column. You could have two scores which are very close to each other,
Yeah.
way off the best.
Yeah, so I think I need to try and do a big number take away a small number is less than a big number take away a small number. But I need, yeah, I need the difference between my answers to be small as well. There's a lot of strategic thinking going on. I'm pleased to see that other people in the chat are agreeing with me, because what I've got written on my piece of paper here that you all can't see is 61 is less than 63, which is definitely true. I'm very happy that 61 is less than 63.
So do you want somebody to talk us through? Do you want to talk us through how
I can talk you through my thinking unless anyone else wants to volunteer in the chat.
And I'll scribe as you go along, whether it's Alison or one of the
somebody else.
participants. Yeah.
Does anyone else want to share their solution? I'm just really pleased with myself because I got a solution. But it's not the Alison Kiddle show. Other people can have a go too.
But it is important, Alison, that we give students problems where the answer is not immediately obvious, where they've had to think quite hard. The maths that you had to do wasn't very difficult, but the reasoning might be quite sophisticated. And at the end of the day, if you get the right, or close to the right solution, you feel really quite pleased with yourself. Sometimes working through 10 similar questions out of a textbook doesn't quite have that feel.
The sense of satisfaction when you solved a problem and convinced yourself and convinced somebody else that you got an answer. No one's volunteered.
So let's have the Alison Kiddle show.
Well, let me talk through what my thinking was. So I, having seen Andrew's brilliant strategy for the adding one, I thought if I put, I want to have a big number take away a small number on both sides. And I thought if I have 80 take away 20 and 70 take away 10 are the same as each other. So I can use the 8, the 7, the 2 and the 1 in the tens columns. And then I would have something that was like the same on both sides, and then use the units to fine tune it to get the inequality correct.
And this could
so if they were all zeros, I would have 60 on the left and 60 on the right.
And the 8 and the 2 could have gone here.
Yeah.
The 7 and the 1 could have gone on the left.
Yeah,
so.
I had them the other way around, but it doesn't matter, because at the moment, if they were all zeros, it would be an equals rather than a less than. And then I have to choose where my units are going to go to make it less than. So I've got the 6, 5, 4 and 3 left. And then I remembered Andrew's other thing from the addition, where he got 2 things that were the same and then couldn't use them and then moved away from it. So I can't have 6 take 4 and 5 take 3, because they would both be 2. So instead, what if I have 6 take 3 and 4 take 5? So I need the 4 and the 5 on the left.
But
so
I'm going to put them in the opposite order. I'll put the 5 there.
Yes.
And the 4 there.
Yes.
And the 6 and the 3 there.
Yeah.
And so this does indeed give us 61 is less than 63.
And I think it would be brilliant if you had some lower key stage 3 students, year 7s and year 8s, being able to confidently talk through and convince their peers that that was the best solution. That would be a really nice bit of mathematical thinking to be going on in the classroom.
And what I like about this version is that we're having to think about what's significant. Well, the positive value of the 2-digit numbers on the left, so we put the high 8 and 7 there, but also significant with the subtraction is that we want to subtract as little as possible. So we're putting the smallest values, the 1 and the 2, in the tens column of the number that's going to be subtracting. And so we're sort of combining the thinking of everything that's happened so far. I don't think we have time for the other two versions of more less is more, but just to whet your appetite, and I think Alison's going to show you on the screen in a second, we do have a plus and a minus version. So you want this to be smaller than that, but you want that to be as large as possible. So interesting, slightly more challenging. And there is another version where you have a subtraction at the beginning and a addition at the end. But that's fun. That's happens to be a lot easier. If we have time at the end, we might come back to this, but I suspect it's best to move on. And then we'll come back to this if we've got a spare couple of minutes at the end.
Okay.
I'm going to stop sharing my screen now. There we are.
And I'm going to start sharing mine. So let me show how to get to. So this is more less is more, but just to show everybody how to get to it. I think I put the links in the chat already, but if you lose those links and you want to be able to find it, at the moment you can get to more less is more by going to the NRICH homepage, and if you go to the secondary teachers homepage again, there's something on the right hand side that has the latest feature. So this is the tasks that are currently live on the site. You've got more less is more just there. You can see it says live. So if you do this in the classroom with some students, then you can get your students to submit a solution to it, which is rather nice. And then I think at the end, Charlie's going to show you another way to find this problem as well.
Do you want to scroll down on this page a little bit? So there are the some, take some, and some take. And there is a printable worksheet if you want to give students the ready-made boxes.
Yeah. But you can just as well get them to draw it out in their book.
Just like I've been doing.
Yeah. Okay, I want to move on then to problem. I'm not going to show you the problem immediately. I'm just going to show you this image taken from it. And so I'll tell you shortly what the problem is called. But what I'd like you to do is I'd like you to look at this part of a number line that I've put on the screen, and you can think about this as well, Charlie. And I'd just like you to pop in the chat anything that you notice about this number line and anything that you can sort of work out by looking at it. So we've got a number line, we've got two numbers marked on it that I hope you can see, and just pop in the chat any observations that you have about the number line. So we've got a conjecture about what the number line is going up in, what the divisions are between them. Be interesting to see if anyone agrees. I'm going to have a question for you in a minute, Fatma, which is about how you worked it out. Okay, we've got some agreement. Can anyone either write in the chat or pop their microphone on if you'd like to explain how you worked it out? Oh, brilliant, we've got the explanation coming. So the difference between 29 and 9 is 20, and then you've counted that there's 5 divisions between 9 and 29, there's 5 spaces, so 20 divided by 5 is 4. So the number line is going up in 4s. So that now means, now that you've worked that out, I could point to other places on this number line and hopefully you'd be able to count on or count back to say what it is. So let me show you the activity that this was taken from. So this is part of Number Lines in Disguise. It's the very first introductory part of it. So I'll pop the link to this problem in the chat for you as well. And so a lot of the problems that we've looked at so far have been thinking about place value in terms of significant digits. And although they felt quite sort of key stage 3, I think there's thoughts from that would feed into key stage 4, and sometimes you would come across classes that spending half an hour on some of the ideas in dicey operations and less is more would be quite useful. And I think it's exactly the same with number lines in disguise. This is flagged up on the website as an age 7 to 14 problem, so key stage 2 and 3, but there are some foundation GCSE students in particular who I think would really benefit from having a go at this task, particularly when thinking not just about place value but starting to think about rounding. And I'll say a little bit more later on about what I mean by that. But if you're following along, if you followed the link and you scroll down, you'll get to this interactivity. If you're not, that's fine. You can just have a look at it on my screen. I don't need to zoom in. I think that's fine. So on the interactivity, every time I press refresh, it chooses another 2 digits to put on the number line. And so what I'm going to do is I'm going to click through a few times. That looks like a nice one. So I'm going to leave that on the screen. And what I'm going to do this time, differently from the static image that we had at the start, is I've clicked show dot. So the interactivity has generated a point on the number line. And so I'm going to give everybody just a little bit of time to see if you can work out what number should go where the dot is, and then how you would justify that to somebody else, how you would explain your working for it. So Anna's got an answer. We'll see whether people agree with you. I think this is a nice gentle one to start off with. Okay, so Anna, would you like to explain? You can either unmute or you can pop it in the chat. How did you decide that that number there was going to be 21?
Yeah, sure. So obviously it's going up in threes using the same principles before. So 30 divided by the 10 to get 3. And then we're going 5 places across. 5 lots of 3 is 15 plus a 6 is 21.
Lovely. Did anybody do it a different way?
I did.
I heard 2 voices there. One of them was Charlie's. I want the voice that wasn't Charlie's. I didn't see who it was, sorry.
It was me, Andrew.
Oh, hello, Andrew.
I saw that the dot was in the middle, so
Okay.
I found the middle of 36 and 6. Add them together, half it, 21.
So you did 36 plus 6 is 42, and then divided by 2 to get 21. So you were almost finding the average then, the median, I suppose.
Yeah.
Yeah. Lovely. So that's the nice thing about the interactive version, because it can generate things that can be thought about in 2 different ways, because it can put something that is that can be divided. And so we're almost starting to think about fractions and equivalent fractions in there as well. But then I can reveal the answer and I can show that it is indeed 21. The other nice thing about this activity is that the ones that I've shown you so far are level 1, but this has lots of different levels, and I'm showing the answers at the moment, which makes it a lot easier. But there's level 2, level 3, level 4, and level 5. And if I scroll up to where the teacher's resources is, I can have a look at the teacher's resources for this problem, and it explains about the different levels that we've got in the interactivity. I thought it did anyway. It's got the worksheet for the interactivity. So you can have a look to see the sort of examples that you get on each level. But basically, in the first level, it's going to generate things with whole numbers in, and you're going to end up getting fractions as you get to the higher levels. You're going to end up getting to negative numbers, as you get into the higher levels. And yeah, so I think I want to give everybody a chance to have a go at a couple of these, just to see the sort of thinking that you do. I know that some of you will be able to generate it on your screen and have a go for a couple, reveal the answer, give yourself a challenge and try a level 5 one, and then reveal the answer to see if you were right. What I'm going to do though, for anyone who can only see what's on my screen and can't navigate away from it, I'm going to scroll down to this page on the worksheets that's got some level 3 questions at the top, some level 4 and 5 questions at the bottom, so that you can just pick a couple of these and just have a go and have a think about the strategies that you use. And I'm going to give you just a couple of minutes or so to have a go at a couple, and then we're going to have a little conversation about the maths that we're using and what this has to do with the overall topic of place value. Okay, Charlie, I'm going to put you on the spot if that's okay. So if I go back here, it's generated for me a level 5 example. Could you have a go? In fact, let me refresh it a couple of times. I don't like that one. Let's try that one. So can you talk me through the thinking that you would do in order to work this out? And if you want me to draw on the screen at all, I'm very, very happy to do that.
Okay, so could you first of all tell me what 151 add 84 is? Because I want to know how far apart these two numbers are.
151.
One's 84 to the left of 0, one's 151 to the right of 0. So if I add that, I'll get the total difference. Okay.
Is that
now,
right?
I don't know. I'm trusting you. I'm trusting you.
Okay.
Now, I think 4, 5, 6, 7. There are 9 sort of steps.
5, 6, 7, 8, 9. I agree.
So I'd like you now to divide 235 by 9, please. I'm glad you're doing this and not me. 2. Ooh, that's lucky. Oh.
6 9s are 54. Is that right?
Yes, I think so. And I'm glad that you're giving me a fraction, I suppose, though you could have given me 1.1 recurring.
Well, you see, I've been doing a lot of work with a student of mine recently about division and remainder, and we've been getting in the habit of writing our remainders as fractions, because if you've got it as a fraction, you can always turn it into a decimal if you need to. But if you write it as a decimal and then you need to turn it into a fraction, then that can be a little bit more of a pain. So that's why I put it like that.
Yes, but nice, interesting conversations, because if a 9th is 0.1 recurring, then 2 9ths is 0.2 recurring, and 3 9ths is 0.3 recurring, and 9
9/9
is 0.9
is
recurring.
0.9 recurring.
And we know that
Lovely.
9 9ths equals 1. So does 1 equal 0.9 recurring?
Yes,
Or-
of course it does.
So a nice discussion. It's not so obvious to students that this is
It isn't. I've been involved in many arguments about that over the years. Okay,
Okay,
so you know that each of these is 26 and 1/9 then. So what
Yes,
are you going to do next?
if I was being really concerned about this, I could just check by adding 26 and 1/9, but I'm not going to bother doing that. The dot is 3 to the right of 151. So I want 3 lots of 26, which is 78. 3 lots of a 9th, which is a 3rd. So I'm going to add 78 and a 3rd to 151. And I imagine I'll get
59, 229 and a third.
Yes. So
Okay,
come on
this
then.
is the moment of truth. We're putting our
Reveal the
professional reputations on the line here, Charlie. I expect people to use the clapping emoji in the chat if we get this right. 229 and a third. So I wanted to show the process of going through one of these, just to show all of the bits of maths that are going on. Because as I said, even though this, thank you, Anna, even though this feels like quite a key stage 3 task at the very beginning, when you just do the level 1 things, and it would be appropriate for key stage 2 as well, I think by the time you get to level 5, I can imagine giving this to a year 11 group to do as a warm-up at the start of the lesson, because it's got in there the problem solving and reasoning to figure out how to do it, and then it's got the practice at the division using fractions, multiplication. You know, for a foundation GCSE class who needs to be able to do stuff like this for the non-calculator paper, it would be a really nice thing to do. But it's also very relevant for this topic of place value and rounding that we're talking about today, because I don't think we always do enough work with number lines at secondary. I think we do more than maybe my maths teachers did 25 years ago when I was at school. But the number line is such a powerful tool, and spending time getting students fluent with it is really good for them thinking about how numbers compare to each other. And so when you're rounding, you know, if I'm thinking about what these intermediate numbers are and how I work them out and where things are on the number line relative to each other, that's the skill set that I need when I start thinking about rounding. Because lots of children, when they are doing rounding, do it by following a procedure. They look at the number and then they look to see whether this is 5 or more or 0 to 4, and then they decide what to do with it. And because the procedure becomes divorced from what it's actually physically doing on the number line, then, you know, it gets forgotten and mistakes get made. But thinking about rounding, decimal places and significant figures all together in terms of the number line, I think can be a really powerful way to link the procedure to something meaningful. And we know that whenever procedures can have meaning applied to them, they're more likely to be done correctly. I think that was all I really wanted to say about number lines in disguise. I don't know if you've got anything you want to add, Charlie, before we go on.
Well, I'm just looking at your screen. It's quite nice. I didn't want to go up in 26 1/9 to check that I've got to 151, but I was thinking, actually, there is a quick and easy way of doing this. Each step is 26 1/9. If that means I'm going to do 9 lots of 1/9, which
is
I know
1.
comes to 1. So let's put that aside. 9 lots of 26 is 234, plus all the 9ths that are up to 1, I get the 235 that I wanted. So if I'm slightly anxious about division, but I can do multiplication more easily or more confidently, I can multiply 26 by 9. And if I get 234, then I know that I've done the division correctly.
Yeah. But I'm a huge fan of number lines, and I've met students who feel as if they're not allowed to use an empty number line as a strategy. And a lot of this comes from what happens in upper primary school when, in preparation for Key Stage 2 assessments, they find themselves having to do particular methods for calculation, and sometimes they're not confident with the methods, and sometimes they can't remember how to do the methods. I mean, you can see here I very happily drew myself a bus stop to do my division, because I'm quite competent at doing bus stop division, although even then I was still worried about getting it wrong in front of everybody. But yes, with those written procedures, even if the procedure doesn't always work for them, you know, the research shows that some kids go for those because they think that's the proper way to do it, and helping them to realize that they can also use informal strategies like empty number lines and adding on and doing checks by using inverse operations. You know, I've done the calculation as a division, so I can multiply to check that I've done it right. That's actually, I think, more mathematical than using a prescribed method, because all of the high-level smart mathematical thinkers I know have checks, and they use things like visualizations and sketches to help them to work things out. So even if it's not entirely about place value, this activity, it's definitely about the thinking that you need in order to do rounding, and it leads to one of my favorite tools for using when calculating, which is familiarity with the number line. So that's why I snuck it in here, even though it might not be quite as place value-y as the tasks that Charlie shared earlier. Now the final task that I wanted to share must be to do with placing, because it's called Place Your Orders. So it definitely belongs in place value. I'll pop the link in the chat a bit. It's actually, again, this is more about estimation, which I think estimation is orders of magnitude. It is to do with the idea of quantity and number sense. And so again, that's why I wanted to share this this afternoon. But Charlie, I'm afraid I'm going to make you do some work again for this. So I'm going to explain the concept of this problem, and then you're going to have a go, and then everybody else is going to have a go. So in this problem, we have got 1, 2, 3, 4, 5, 6, 7 different categories. So there's the number of, there's the distance, there's time, there's speed, there's mass, there's area, and there's volume. And in each of those, there are 4 statements. And the idea is to work out what order they go in from smallest to biggest. Now, we don't have time to do all 7, and we don't have time to do all 4 things in all 7. But do you want to choose one of these categories, Charlie? What do you fancy?
I think I'll go for the mass, because I can see one of the 4, something that I could estimate quite easily.
Okay, so you've got the mass of a standard family car, the mass of 1 million cubic centimetres of water, the mass of a team of international male rugby players, which is 15 players, if you didn't know. I don't know very much about rugby, or the mass of enough potatoes to make chips to feed everyone in the school for a week. So people might want to comment in the chat how big they think some of these are. But Charlie, what I'd like you to do is I'd like you to talk me through your thinking for any of these to try and put an approximate value for the mass. And I think we'll probably work in kilograms for this rather than pounds and stone, because we should use metric units.
So the reason I chose this one is that, yes, I know my weight in kilograms. So
Okay.
I weigh 72 kilograms. And almost all international male rugby players are bigger and taller and heavier than me. So I'm going to assume that on average they are about 100 kilograms. I imagine they may be just a little bit more, but I'll stick to 100 because I can multiply 100 very easily by 15 and get 1,500 kilograms.
Okay. I mean, I'm a bit worried because I have watched a bit of rugby before, and I know you get these little ones that do some of the kicking and stuff. Do you think that the heavy ones are going to be sufficiently heavy to make up for those weedy looking ones?
I think the little ones look little because they're next to the big ones. And even the little ones are bigger than me. And I
Okay.
think then the big ones are a lot bigger than me. And I think there are some 120 kilogram players there
Okay.
at the front of the scrum.
Yeah, and then they do say that muscle weighs more than fat anyway, doesn't it? So they're all incredibly muscular, so very dense too. Okay, so our estimate then for the rugby players is going to be 1,500 kilos, yeah?
Yes.
Okay, I wonder if anyone in the chat would like to estimate any of the others, and you can tell me what you think about them. What about
the idea, Alison, is eventually to be able to sort of place them in order.
in order?
The lightest at the beginning and the heaviest at the end, or vice versa.
Yeah. So
okay.
do you think the rugby players are heavier or less heavy than the car then? If I put a team of rugby players on one side of a seesaw and I put a car on the other side, which side do you think would go down?
I hope you're asking everybody that and not me.
I'm asking you and everybody. See, everybody who's watching has the advantage of being able to pop open another browser window and just type into Google how heavy is a Ford. That's a kind of car, right? How heavy is a Ford? So somebody Google it for us. How heavy is a family car? Meanwhile, I think we can definitely do the cubic centimeters of water.
Do you want me to talk you through the cubic centimeters of water?
Andrew thinks it's 1,000 kilos. I think Anna has just looked up a car for us and found it's 1,500 kilos, which is really unhelpful because that means our car and our rugby players are going to balance. But the water is definitely going to be less heavy if Andrew's right about 1,000 kilos. Do we agree with Andrew's 1,000 kilos? What do we know about water? Is a cubic centimetre a gram?
I know that 1,000 cubic centimeters is a kilogram. Because I picture 10 by 10 by 10 cube, which is a litre.
Yeah, so that's one of these things that it's really useful to know, and I think kids will definitely have met this in their science lessons at some point, that the density of water is such that a litre of water weighs a kilogram and a litre of water is also 1,000 cubic centimeters of water. But it's also something that can be quite easily looked up. If they've never come across it before, it will be a fairly straightforward thing to go away and research. So if we've got 1,000,000 cubic centimeters, we had our 1,000 cubic centimeters is 1 kilo. So 1,000,000 cubic centimeters is going to be 1,000 times 1,000. So that's 1,000 kilograms.
The other thing about, Alison, the other thing about the 1,000 cubic centimeters and the kilogram and the litre is that I can sort of picture my 10 by 10 by 10 cube, and I can think, oh yes, when I buy a litre of milk or of juice, yeah, that's the kind. Whereas I find it much more difficult to picture a cubic centimetre and a gram, because I don't really know what a gram weighs like. Whereas I'm used to picking up a litre bottle out to a supermarket shelf, and that I find much easier to remember or to appreciate.
Yeah, it's this idea that, you know, there are units that we use every day that we have a much better sense of. And I think that's actually quite useful when thinking about the potatoes question, because in my head, I have that an apple is about 100 grams. When I'm trying to remember what 100 grams feels like, the thing that I have in my head is that's about the same as cubic centimetre was 1 milliliter and 1 gram. Yeah. So 1,000 cubic centimeters is a kilogram. Yeah, sorry, I was just distracted by the chat. Yeah, so in my head, an apple is about 100 grams. And so for the potatoes question, I think what I would do is I would try and think how many people there are in the school. If I was just feeding them potatoes instead of chips, how many potatoes would I want to give each person? And maybe do jacket potatoes instead, because they're healthier anyway, right? And we want our rugby team to be able to, develop muscle rather than fat. And then I can sort of estimate it up. But the interesting thing about this one, I think family car, cubic centimeters of water, and rugby players, we could actually go out and find definitive answers for all three of them. We could do some research into the family car and find what the range of values is, and then go for the middle value as a sort of standard average. Million cubic centimeters of water is sort of set as scientific fact. And then team of international male rugby players, I could go and look the statistics up online for the current England team or something and work that out. But the potatoes one, this is very much a movable feast, because I would hope that students would say it depends on my school. Because if I attend a small rural school in the Highlands of Scotland, the answer might be quite different from if I attend a very, very large academy in the middle of London, because everyone in the school is not the same for everybody. So there is not a correct answer to this question. The idea of this activity is about the justifications that you do. So I want to give everybody just a couple of minutes to have a look at these. I'm going to leave on the screen these top 4 ones. And what I'd like you to do is I'd just like you to pick one of these 4 and to pick 2 quantities out of it, and then decide which order, which way round they go. So you might choose from the distance. You might choose the distance you can hop in 5 seconds and the distance from the penalty spot to the goal on a football field, and then come up for yourself an argument about which way round they would go and how you would justify that. And so I'm just going to give everybody maybe about a minute and a half to have a read through and decide on the ordering for 2 of these quantities. Okay, I've not given you very long. If anybody does want to pop in the chat the 2 things that they thought about and compared, you're very welcome to. While you're doing that, then I want to talk a little bit about ways that this activity might be used in the class and the sort of thinking that might come out of using this. So I was very lucky a few years ago to be invited into a school to do some work with the teachers there. And while I was there, I visited some classrooms and saw a teacher using this task. They didn't know that I was going to be coming in and visiting. So when I came in, and I said, "Oh, I wrote this." It was really lovely for the teacher and the students who all got a really nice buzz from that. But what the teacher had done was they'd separated out each of these things. They had a class of about 30 students, and they'd split them into 7 groups and given each group responsibility for one of these things and gave them some time to research. I think they'd had it as their homework at the end of the previous lesson, and they had to come back to the lesson so that in their group they had all the information they needed to do the calculations. And then they had to sit down, do the calculations, come up with their arguments about what order they went in and why, and then prepare a presentation to give to the rest of the class, which the rest of the class then watched and critiqued. And what I thought was really nice about this is that the students were given lots of ownership of the task, and what they were effectively doing is they were doing some mathematical modelling. There were unknowns that they then had to decide about. You know, they had to decide, how many people are we going to say there is in a class? How many people are we going to say, are we going to assume it's our school, or are we going to assume it's like the average school? I need to go and find out some information about where penalty spots are in football fields. I did this activity once with a group of trainee teachers, and some of them started doing how far could they hop in 5 seconds. So they were hopping across the back of the classroom, and then somebody else walked past and said, what on earth are these students doing? It's making the floor vibrate downstairs. But there's a lot of activity that goes into justifying it. But you're also, as well as doing all of that mathematical modelling and so on, you're thinking about orders of magnitude, because if two things are about the same order of magnitude, you then have to go into a second significant digit in order to be able to say which one's better, which one's bigger. But if one of them is a completely different order of magnitude to the other, it's really easy to say which one is bigger. And I think this idea of orders of magnitude and significant figures is something that a lot of people take quite a while to get a handle on and to understand. And yet when you are estimating, knowing what the significant digit is really useful and really important. And, you know, it's what I do when I go shopping. I have a running total in my head of roughly how much I think I've spent. And this is going to become an obsolete skill now, because all the supermarkets have got the scan as you shop things, so you can see exactly how much you spent. And I think I'm the only person who still goes to the shop rather than ordering everything online. But you can keep a running total as you're doing a grocery shop of roughly how much you've spent. And you know that there are some things that you can just throw in the trolley and it's not going to make a big difference to the total, because you happen to be buying, you know, large, expensive things that are going to dominate. So it's right back to where we were at the beginning about where you were putting the numbers within the dicey operations, and the less is more. So Anna has compared the distance statements 1 and 2, and claims that she would not be able to hop the distance of one story in less than a second. So you've got 5 seconds and you've got a 6-story building. So you've done some lovely scaling there to say the height of 1 story, you wouldn't be able to hop that far in 1 second. So the hopping is definitely less than the distance from the top to the ground. So that's the sort of really lovely justification that's used lots of mathematical thinking, that it'd be really wonderful if students had a chance to do. Charlie, I would like to hand back over to you, because we're very close to the end, but I'm keen that everybody knows what's going on with the mapping document and how to find it. So if I go back to the home page, can you tell me how I would get to that, please?
Okay, just to add one thing to, you've been talking about significant figures. What I liked about, well, what I like about dicey operations and less is more, is that we spoke about which are the significant figures without having to give any formal definition to what we mean. In the same way that you were talking about the number line helping students understand what they're doing when they are approximating and rounding, and that they've got this image and model. Actually, the first couple of activities we did this afternoon, the word significant can arise in discussion without it necessarily having that formal mathematical meaning that we often give it. And so students get used to, oh, which are the significant, what's most significant? These are the ones that we're going to fill in first, for example, or these are the ones we're going to be, we're going to make sure we don't fill in at the very end. Anyway.
Yeah, and significance is sort of fundamental to the idea of place value, really, because the digit signifies something in terms of a power of 10.
We're having slight difficulty with your connection, Alison. We can't hear you. Can you hear us, Alison?
My video, can you hear me now?
We can hear you now, yes.
Right, tell me where to click then.
Okay, for the mapping document, I would go to the secondary teachers dark green lozenge there on the right. Click on that. And then on the left-hand side in the green cell, we've got secondary curriculum, and I'd click on the secondary one rather than the post-16 one. And then the first link on that page is to the curriculum mapping document. And it's set at, we've got different pages. At the bottom, you can see we've got a number page, we've got an algebra, we've got a geometry page, and we've got a statistics page. We've been working on number today. So if you click on number, then at the top of the number, it starts with place value, integers, ordering and rounding. And in the year 7 column, so the far left column, in the very first cell, we've got links to dicey operations, and more, less is more, is just below that. So those two problems appear there, because if we look at the cream colored row, it talks about understand and use place value for decimals, measures, and integers of any size. Now, below that, we've got number lines in disguise, which is the other one of the other number problems we used. And then in the year 8 column, and when I say year 7 column and year 8 column, we're sort of thinking about an average student. Of course, you may want to use year 6 problems with students who find maths very difficult, and you may want to be showing some of your year 7 students some of the problems that appear in our year 8 column. But there you can see, place your orders at the bottom of your screen is the recommended task for rounding numbers and measures to an appropriate degree of accuracy.
Yeah, and although everything today has been sort of year 7 and 8 column, this is sort of like the first place that you might introduce them. And as we've said throughout, there's benefit to using some of these things right up into Key Stage 4 as well. And the seeds that you're planting with these things are then going to go right through.
It's worth scrolling
I
down,
think
Alison, just to show that in the number page, there are
there's loads.
Key Stage 4 activities. It just happens that place value gets...
It's quite a Key Stage 3 topic, isn't it?
Yeah, so there we are. With factors, multiples and primes that you just had, there were plenty of year 9, 10 and 11 tasks.
Yeah.
And later on, towards the end, towards the bottom of this page, I think there are more year 9 and 10 tasks than there are year 7 tasks.
Right, I'm conscious that we've got -3 minutes left to go, and that Ellie still needs to sort of say goodbye to everybody. So let's stop that there. Hand back to Ellie just to finish off, but to say thank you to everybody for participating and for joining in the chat. Really enjoyed it, and I'm sorry that my internet connection went wobbly at the end there.
You want to just see whether the camera works and we can see you. Okay, then you can give us a wave. And just to confirm what Alison said earlier, we'll send a link to Ellie to all the problems that we've talked about, and we're going to ask her nicely to forward that to you all. So don't worry if you haven't made a note of more.
Thanks, everyone.
Bye bye.